16b students, here are 4 quick u substitutions. So the first one, we have the integral of 4x cubed times e to the x to the 4th plus 2. The natural choice for the u sub is x to the 4th plus 2, because the derivative, du dx, is 4x cubed. I usually personally like to write this as du equal to 4x cubed times dx, and then see that, oh look, I have 4x cubed times dx. So that's exactly going to become my du. So I'm going to rewrite this integral as the integral of, I like to write my du's at the end, and then this is going to be e to the u. The integral of e to the u is e to the u plus c, so that's going to be e to the x to the 4th plus 2 plus c. And you can check that this is correct by taking the derivative of e to the x to the 4th plus 2 and getting e to the x to the 4th plus 2 times the derivative of x to the 4th plus 2, which is 4x cubed. So the derivative of this is exactly 4x cubed times e to the x to the 4th plus 2. All right, here's another one. Here we're going to let u equal the denominator. U is x squared plus 7. Du dx is 2x. Du is 2x dx. And 1/2 du is equal to x dx. And I exactly have an x dx. That's going to become 1/2 du. So I'm going to write this as the integral of that x dx is 1/2 du. The denominator is x squared plus 7, which is u. Now I personally would rewrite this as the 1/2 multiple out in front. And you can either write this as du over u, but a lot of people don't like that. You could alternatively write it as 1 over u du. Then the integral of 1 over u du, or du over u, same thing. Got the 1/2 out in front. That's going to be the integral, that's the natural log of the absolute value of u, plus c. And then we plug back in what u is, which sounds like I'm saying bad English. Natural log of the absolute value of x squared plus 7 plus c. That's our answer. You might see people drop the absolute values here since x squared plus 7 is always positive. But you can also just leave it like this. But you could also write it as 1/2 natural log of parentheses x squared plus 7 plus c. Because x squared plus 7 is always positive, so the absolute value doesn't change it, so we can drop them. All right, two more slightly more complicated ones. So here, I'm going to let u equal x cubed plus 5x because I'm pretty sure, well, I know it's stuck inside another function, right? I've got x cubed plus 5x to the 4th power in the denominator. Or you can also write this as 6x squared plus 10 times x cubed plus 5x to the negative 4th. My du, or du dx, derivative of this is 3x squared plus 5. And while I don't have that exactly, I'm pretty close. I can factor out a 2 from the top here and write this as the integral of 2 times 3x squared plus 5 over x cubed plus 5x to the 4th dx. And so I can see that du is equal to 3x squared plus 5 times dx. And this part here, there's my du. So I have got the integral of 2 du. I like to put the du over here, right? You can write it in the numerator or just over on the side. So I got 2 du over, this is my u to the 4th power. I'm going to rewrite this as 2 times the integral of, instead of 1 over u to the 4th, I'm going to write u to the negative 4th. I'm going to use the anti-power rule. So that's going to be 2 times u to the negative 4 plus 1 is negative 3 divided by negative 3 plus c. So you can either write your final answer as negative 2/3 times u, which is x cubed plus 5x, to the negative 3rd plus c, or you can put that in the denominator and write it as negative 2 over 3 times x cubed plus 5x to the positive 3 plus c. Either way, it's a perfectly fine way of writing it. All right, last one. I see secant squared of cosine of tangent, secant squared of x times cosine of tangent of x. So be careful, right? Secant squared of x is just 1 over cosine of x squared. whereas cosine of tangent of x is something totally different than cosine of x. So be careful. It seems sensible to let u equal the tangent for two reasons. One, it's stuck inside another function, right? Tangent of x is inside the cosine function. And two, the derivative of tangent, well, the derivative of tangent is exactly secant squared x. Right? The derivative of tangent x is secant squared x. So du is exactly secant squared x dx. And look, I exactly have that. Sometimes people like to rewrite this. Like I just like to say, okay, there we go. There's our du. But sometimes people rewrite this as the integral of, and they write this part first. Say it's cosine of tangent of x times secant squared x dx, and they're like, oh hey look, there's my du, and hey there's my u. So I'm really just integrating cosine of u du, and that just means integrate cosine of u with respect to u, right? That's what the du means. And this means integrate. So take the antiderivative of this function with respect to the variable u. Antiderivative of cosine of u is sine of u plus c, just like the antiderivative of cosine of x is sine of x. And then finally, plug back in u equal to tangent of x and get sine of tangent of x plus c. And once again, if you want, you can check by taking the derivative. The derivative of sine of some stuff is cosine of the stuff times the derivative of the stuff. So the derivative of sine of tangent of x is cosine of tangent of x times the derivative of tangent, which is secant squared. So you get exactly cosine of tangent of x times secant squared of x, and that's why.